Thank you, and thank you all for coming. I hope you've been enjoying the conference so far. It's interesting, it's always dangerous at a conference to submit an abstract because inevitably the specific focus of the talk kind of evolves as it goes, so we'll see how much I've drifted in what I actually present to you today. So I've already been introduced, and topics have already been introduced, so why don't I elaborate a bit on that background. So, as we said, I built a product called Pregrade, which is an AI essay grading assistant. And you might think, since I'm giving a talk about these frameworks, that I used one of them and I'm now sharing my experience. But actually, I'm coming from the opposite direction. About a year and a half ago, we were going through a major refactor. And at that point, I considered using LangChain. And I actually bounced off it. I actually thought at the time it wasn't really offering a solution to the problems that we were having. And so basically I ended up writing my own mini framework and have since been building on that. And to be truthful, I don't regret that decision. The amount of time I've spent on building sort of the abstractions that we're using has not been immense, and it's very nice to have a tool which is very carefully and closely fit to the specific issues that we were facing. But if anything, these frameworks, in particular LangChain, seem to, if anything, be becoming ever more popular. Recently, actually, I've even been noticing LangChain listed as a sort of requirement on job ads. And people want 3 years of experience using LangChain, which is kind of strange. It's only like 2.5 years old. But anyways, so I wanted to use the opportunity of this conference for myself to return to these frameworks and look over them again with the lens of knowing, well, I basically did it myself. What then could these frameworks offer? And so the point of this talk is not going to be to really introduce in detail what these different frameworks contain. It's not a tutorial. If you want to know that, the best way to get that is the docs themselves or the various tutorials you can find on YouTube or anywhere else. Instead, the question is, how should you think about committing to one of these frameworks or not? And this or not thing is not really a live option. Honestly, at this point, you probably want to use one or the other. The next AI application I make, I'll probably use one of them, and I'll tell you at the end which one that probably will be. But I do think having in mind the option of not, having in mind the option of doing it yourself is a useful lens to be really critical about what you're actually getting from these packages. And being aware of the trade-offs. And it is important to realize there is a trade-off here. So I was thinking about this, and I was thinking about what are these packages? What is LangChain? What is LlamaIndex? In terms of what kind of Python package is it in the ecosystem? And the closest analogy I could think of is that they're really like an object relational mapping package, an ORM. Now, this to me is an interesting analogy because it reminds us to apply some of the skepticism about ORMs that exists in the discourse to these packages as well. So the ORMs, there is a pretty significant contingent of developers who will say that you're not really saving any difficulty or complexity by using ORM. It might seem like you are, but when rubber hits the road and you need to optimize a SQL query, you're just going to write some SQL anyways. And having this extra layer of abstraction ends up being just something new you have to deal with above and beyond what you're going to have to deal with anyways to be efficient in interacting with what you're doing. So we can generalize this point and to say that any kind of framework is going to offer certain tools and abstractions that want to claim to simplify certain complexities that you would otherwise have to confront yourself. But the sort of features and the abstractions of the framework itself, getting to know them does require certain kinds of investment of time and effort. And there's some point at which certain pieces of application logic you're trying to achieve, if there's a mismatch between what you need to achieve and what the framework offers, then making it work in the framework ends up being just a different kind of complexity and not, in fact, any less. So, with all of that setup and motivation out of the way, let's dive into looking at these different frameworks. And here, just kind of a quick sort of 10,000 feet overview. This table here is in a descending order of GitHub stars as a simple measure of the penetration of these different frameworks. LangChain is obviously the most prominent one. I'll say there's a lot here that's quite similar between all of them. They all are licensed permissively. You can use them in commercial applications, no problem. They all offer integrations with various other outside tools. They all have integrations with the major model provider APIs, as well as ways to host models locally. They all have integrations with various sources of agentic tools, including MCP servers. There is a slight difference in that PydanticAI of the four is the only one that lacks integrations with sort of certain RAG pipeline elements. So if you want to have, so if you are processing documents, adding them to a vector database, retrieving from the vector database, doing those kinds of operations, PydanticAI does not have built-in tools to do that, while the others have a quite massive list of built-in tools to handle that kind of thing. Other than that, one other thing I'll sort of note as a big overview is that each of these frameworks, despite being open source and free themselves, have some kind of enterprise offering. For LangChain, that is sort of a hosting platform with LangGraph and observability with LangSmith. LlamaIndex has an enterprise platform which is more about document processing and data access. So it's kind of really a RAG database platform. Haystack is connected with DeepSetAI, which is a development and deployment platform for AI applications. And PydanticAI is linked with Logfire, which is a platform for observability. So, you know, it's always worth noting and thinking about open source. What's the other side of this that pays for it? And those are the offerings that are connected to. Okay. So that's just the very, very broad overview. I haven't really talked yet about what these frameworks do. And in a talk like this, it's always a little tricky where there's going to be a mix of people here who have dealt with building applications themselves, so they sort of know some of the issues that you face. Some of you might be just interested in hearing about this on a much more general level. So I do want to start at the very, very basic level of what is the absolute most basic, simple problem that these frameworks solve. And that's illustrated with these two pieces of code. These are basically the toy, they're not functional, sort of toy AI agents. One using a Google model, the Google Gen AI SDK. One using the OpenAI SDK. These two pieces of code do essentially the exact same thing, and I would expect them, despite being different models, to perform basically the same. But the syntax using the native SDKs of the two model providers, OpenAI and Google, are totally different. And this is the general point here. The state of the market now with large language models is that there are many different models and providers of models and hosts of models available, and basically what they offer is more or less exactly the same. There are differences in capabilities on nuances. You might prefer certain behaviors or certain models versus another, but in the grand scheme of things, if you're looking at OpenAI, Anthropic, Google, even something like Grok, even some of the open source models, you're getting the same broad capabilities. And they basically operate the same way. They all have a concept of messages, which you provide to the model. They all have the ability to define and call tools. All of the proprietary models, certainly, and even some open source models will accept various multimodal inputs. But their syntax and API interfaces are different. Now, why does this matter? This matters because the market is quite fluid. When you start building, you might decide for various reasons that, okay, I want to use, as we did with pgrade, we want to use Azure and OpenAI models, okay? Those were the most available, they were the best at the time, they had a nice range of more expensive and cheaper and faster options, great. But the market shifts a lot because of geographic availability, because of different quota limits that are available at different services, because of generational change, which shifts the trade-off between cost and capability. You might find that you want to switch to some other provider. And using the SDK directly would represent a barrier to this. And so it would be nice to be able to make this switch painlessly, because all of your application code is totally agnostic to the underlying source of the model. Quick aside, to extend on this analogy with an ORM. This is an important difference, I think, between kind of the AI LLM landscape and the database landscape. The database market is much more well-established and stable. It's very unlikely that something is going to happen that's going to make you want to switch from a PostgreSQL deployment to a MySQL deployment. And so that agnosticism is actually not a basic useful thing. So, but again, what these frameworks offer on the most basic level is agnosticism about the source of the model. They offer abstractions which you can plug in whatever source of model you want. And in fact, all four of these frameworks have the same basic set of abstractions to cover these shared features. They have abstractions for messages, they have abstractions for agents, for tools, of course for models, for tracking usage, for standardizing response from models, and for representing history of messages for chat, for maintaining a chatbot, right? These examples here, so I mean, this is a LangChain example and a Haystack example of messages. This is a LlamaIndex example of defining a tool. You can do something similar in all of them. Of course, each framework has a different syntax, but again, they're agnostic to the source of model, so they make that easy to switch. Now, I've talked about on a very basic level what these models are definitely good at, and on a very simple level, what problem they solve. I should also note the other side. I mentioned that I bounced off LangChain because it seemed to not solve the problems I was having. And I just want to mention this briefly. The problems that I was having, and the thing that has been the most time-consuming in building my own package to handle these problems, is actually something that none of these frameworks seem to do much to solve. So very briefly, I said we use Azure OpenAI. Azure OpenAI has a concept of deployments of models in different regions. And this is important because quota and throughput is per model per region. So if you want to increase the maximum throughput of tokens that you can have, you have to spread out requests across different models in different regions. Also, sort of performance seems to occasionally fluctuate based on model and region. One region and one model will have some problems, really slow responses, just timeouts, and you want to be able to fall back to some other model in some other region, okay? these are the problems we were actually facing. So dealing with load balancing and dealing with fallback for network problems. And basically, these frameworks don't offer any solution. PydanticAI offers a bit of this, but even then, it's not really a sort of first-class solution, other than sort of fallback. They do have that; the others do not. Okay. So that's what they're good at. A few things that, interestingly, are holes in all of them. The actual question, though, that I want to raise was, okay, how do we decide then? When we're looking at these different frameworks, how do we decide to choose one rather than the other? And on this point, I want to make an observation about these frameworks. When you go through the documentation of these frameworks, there's let's call it a bifurcation. On the one hand, you have a lot of what I could call features. These typically take the form of classes that are pre-built and come out of the box to do certain things you might want to do. You might have a prompt template class. LangChain has classes for selecting examples for few-shot learning. Each of these frameworks has lots of these pre-built elements that will just do one thing. That's the one side. The other side is that they offer some kind of lower level interface to build and extend your own more sophisticated custom logic. So those are the two sides. The pre-built simple stuff and some kind of lower level system that you can build on. And the thing I want to suggest about this decision about whether and which framework to adopt is that that decision should depend not on the features that are available, but on the extensible lower level interface. And this is, to show my hand a little bit, of the four frameworks I'm looking at here, on the first side, on the feature side, PydanticAI is very clearly the least comprehensive. But for myself, and I'll sort of talk about why, if a question is how do we extend it, I actually think it might be the one I'm most comfortable with. And this is going to be a question of comfort. How you feel comfortable building on one of these frameworks will come down to the style of coding you like. And that's the kind of question you have to ask. So, to actually illustrate this, I want to offer some specifics about what's really a very rudimentary problem in AI app development. And that is validating the output. Of course, LLMs give text as output, but typically we don't want plain text. We want some kind of data. So we need to instruct the model to return the result in some kind of format which we can parse, validate, and manipulate. So, I mentioned that app I built is with Motivate is a AI essay grading assistant. So, with an AI essay grading, one piece of information we get from the teacher is a rubric. It tells us what the teacher wants to grade on and tells us the possible scores that we should be giving to an essay. So we need to have the model give us some format that's going to allow us to parse out scores and comments which cover all of the elements we want to grade on, here, grammar and content style, and give us a valid score, 0, 1, or 2, for each. If we're missing some, or if there's a score that's not here, we have to go back to the model and say, okay, no, this is not right, fix it. It's pretty easy for the general structure of this, for the sort of the general structure of the output we want, to just define a pedantic model that sort of defines a score, defines a comment, And we basically going to ask it to create an object that's a list of scores, a list of comments. Right? That's going to be the basic structure we want to get back from the model. 3 of the 4 frameworks, LlamaIndex, LangChain, and PydanticAI, offer very, very simple, out-of-the-box support for defining a schema, often simply by just giving it a pedantic model, and the framework will handle checking whether the results from the model can be parsed into that. If not, retrying with instructions of what to fix, and then giving you the parsed result. So I have here, this is basically what you do. It's very, very simple in all of them, right? You basically just are giving the class to, in a single line, and they're going to give you what you need. But this is not enough. This is not actually what I need for even this very simple problem. Because again, I don't just need the result to be any valid object. I need the data or the content of that object to fit certain requirements. I have to have, again, all of the elements the teacher wants to grade, and the scores have to be valid, given on the options that I provided. So I need to have some way to not just check that it parses, but to check that logic. And what we see here, even again on this very rudimentary point, that this one-line solution is not going to work anymore. We're going to have to jump down to a lower level of abstraction in these frameworks to solve this problem. Okay. Some of you who know Pedantic might be saying, you can do this with a dynamic pedantic model. Let's just put that aside for now. Because we still, let's say we want to do it in the framework. We don't want to do a dynamic pedantic model. That syntax is kind of messy. We want to do it in the framework. To put this in more general terms, the question, what we're seeing here is something that we could call a complexity stair step. The stuff that's clearly covered by the pre-built features of the framework is very, very simple. And there's going to be a certain range of options that we're going to be able to tweak with parameters to make those simple tools work. But once we cross outside the umbrella of that simplest solution, we have to take some kind of step down to a lower level of abstraction to have the extensibility we need in the framework to solve the problem that we actually have. And the question we want to ask, the question we want to be thinking about before we start building with any of these frameworks is, how steep is that step? And how much am I going to have to refactor what I've already written to make use of that lower level? I'm gonna sort of give a brief demo of what actually that would involve, what this lower level looks like in each framework in a second. Let me just note first a difference of emphasis among these frameworks. LangChain, Haystack, and LlamaIndex, Haystack, and LangChain up until version 0.3, I mean the current stable version, seem, in my reading, to very much emphasize in their documentation and in their structure the large list of pre-built elements that they offer. That's their emphasis. And then there is, separate from that, something, the lower level thing. In contrast, PydanticAI and the emphasis of the V1 of LangChain, which is currently in alpha, seems instead to be more interested in offering you a relatively high level, but still very extensible scaffolding. So let me show you what I mean here. So first, I wound up with Haystack because Haystack doesn't doesn't have a built-in way to validate an object. The solution to get simple validation and the more complex logic is actually the same. And since this is less code, and so it'll be not tiny on the screen, let's look at this. Haystack's lower level abstraction is based on the idea of a pipeline. A pipeline is a container in which you place components. Each component has certain inputs defined as parameters and certain outputs. I think of them as output channels, which you send the output of one component to a channel by returning let's look up there, a dict where the key is the channel. You add those components to a pipeline and then connect the output channels of one component to the inputs of another. So to get the validation here, you have a validator component, which when there's an error, you send that back up to what you actually sent to a joiner here, which does stuff with the messages, which then sends it to the LLM. So that's that. And again, this is the more complex. It's very small, but it's the same basic logic, right? We're already on the lower level abstraction, so it's basically the same as what I just showed you. Huge contrast here. PydanticAI. Again, what I said, PydanticAI offers a relatively high level but extensible scaffolding. So it's a little more complicated to define custom validation logic than just giving a model, but it's actually as simple as adding a decorator to a function. When it's wrong, you can simply raise an exception, and this is then passed back to the model, and it's told to fix it. LangChain 3.1 is likewise has a scaffolding built into its agent abstraction, which makes us relatively sort of in line with simply building an agent. It's a concept called middleware. You define a middleware object, a middleware class. You define a hook, and you return instructions as a result of that hook. So if it's not, again, if it doesn't validate, you simply are sending certain messages back to the model. In contrast, LangChain 0.3 and LlamaIndex are, again, you are stepping away from the pre-built elements into a quite different lower level language. In LangChain, this was called LCEL, which involves wrapping various things in these runnables and connecting runnables together. I'm running out of time here, so I won't kind of go into quite so much detail. But and LlamaIndex is very different. LlamaIndex it's their framework. They call this workflows. This is a event and step-based system where you define your workflow as a class, decorate different methods as steps, and you control the connection among steps by defining events. And so a particular step takes a certain event, and when that event happens, it comes in, it has certain data, and you control where you go next, the next step, by the event that you emit by returning. Again, the point here is not to go through a tutorial how to use these. The point is to show how different the ethos of how you build on these different frameworks would be. And to say that I really think that that is the key thing that should guide a decision. Let's call this the highest level of extensible abstraction. You should expect to have to use it. And so the decision of which framework to use should be based not on all the classes that are already built for you to do certain things, but instead how you think you'd feel having to work in one of these idioms, whether that's this kind of workflow, whether this LCL, and so on. And for me, I think that, just as the upshot, despite its relatively shorter feature list, I actually find the PydanticAI H abstraction really interesting because it's still relatively high level, but has a tremendous deal of customizability. So, thank you all for listening. I don't think we have much time for questions because it's been half an hour, but please do feel free to reach out. The text and slides are on GitHub. The code is not yet because I lost half of it as I was doing this, and then what I have isn't actually running. So I will see if I have time to return that. I might actually give running examples now. So thank you all again. I hope this was helpful.